Okay, hello everybody. This is Tracy Reagan, CEO of Deploy Hub. Deploy Hub hosts these CDF Online Meetups, and we're honored to do so, and we're starting to get a nice following. So thank you everybody who has showed up today. Today we are going to learn about Argo. I know that Argo is not part of the CD Foundation, but we are we're happy to learn about lots of different CD tools, and this one in particular I've been very curious to learn about. I met Isaac. I reached out to him on a LinkedIn chat, and we started chatting about different tools, and he mentioned his experience with Argo CD, and I immediately wrangled him to do a presentation for us. Isaac has served as a cloud engineer, DevOps engineer, SRE for a lot of high-tech companies, and including companies like Tesla and GoPro and Code42. So we are super happy to have him here, and we appreciate his efforts in putting together this presentation around Argo CD. Just an announcement for our next session, our next meetup. Let me quickly look for us. Is going to be on. We have butter knives to samurai swords, elevating developers to ninja warriors. So this one, I try to mix kind of process presentations with tools presentations. This next one, it's going to be held, I believe, I don't see the date here. It's interesting. November 10th, 12 p.m. to 1 p.m. Mountain Time, so I believe that is an hour earlier, but November 10th. This is going to be presented by Guru Mani. He is the Director of DevOps and Quality Engineering at Markel Insurance, and he's really going to talk about how they have upskilled their DevOps teams and their DevOps practitioners. So that should be an interesting one. Again, it will be, again, more of a process presentation than a tools presentation. And on that note, I am going to introduce us to Isaac Gaskin. Isaac, it is all yours.
Awesome. Thanks for the introduction, Tracy.
You're very welcome.
Let me go ahead and share my screen. So yeah, like Tracy mentioned, I'm going to be talking about Argo CD and specifically around the topic of continuous delivery and GitOps. I'm going to make a disclaimer up front that everything that I'm about to share are my own views and opinions. I'm not representative of my employer. Cool. So this is kind of like an overview of our agenda. We're going to talk about GitOps, kind of the history of it. We're also going to talk about the architecture of Argo CD. So we're going to go a little bit deep in terms of the design of the platform as well as how it interacts with different subsystems. And then we're going to spend a majority of our time actually demoing the tool. So you'll kind of get to have like a hands-on walkthrough of what it looks like to use Argo CD from like a day-to-day operations perspective. So brief history on GitOps. GitOps is actually a term coined by Weaveworks, and it built upon these principles that have been well established in the industry. So there's plenty of tools that do configuration management and infrastructure as code. And I'm just going to use the umbrella term of infrastructure as code to reference all these tools. So these are like well-established tools in our industry, things like Chef, Puppet, Ansible. Terraform is a large player in this area as well. And the goal of these tools is really to establish your infrastructure in a declarative way. So everything about bringing servers up to configuring them is all defined in code. And this works really well. And GitOps actually builds upon these principles and trying to take it a little one step further. It tries to answer questions such as, what if the system diverges from the source of truth? How is the state reconciled? Are there alerts that are fired if you're experiencing drift? And then also, how do you trigger convergence? How do you converge the expected state with the actual state? So GitOps builds on all these principles, especially that of immutable infrastructure, which is somewhat of a solved problem in this space right now. So this is taken from Weaveworks. They kind of call out these 4 principles of GitOps, and I'll have some references at the end of my slides if you want to look a little bit more further into some of these things that I'm referencing. So first off, the entire system is described declaratively. So that means that everything about your platform is in code, and declarative means that it's going to be immutable or hermetic. So when you define it in code, you can have a guaranteed assurance that when you create it today, 5 days from now, 5 years from now, it'll come up in the exact same way. Secondly, in GitOps, everything about the canonical state of the system is versioned in Git. So this is like a multi-beneficial thing because first off, Git is like very natural as a tool for developers in developer workflows. Everyone knows how to use Git and version control. Not everyone is like an expert on a lot of these like niche configuration management tools. A lot of configuration management tools introduce DSLs or domain-specific languages that you need to understand and learn, as well as just a tooling platform to actually execute the declarative files that you're generating. So Git is like completely streamlined into the developer workflow experience. Also, because Git is a version control system, you just like out of the box get like a disaster recovery, a rollback plan, because at any point in time, your rollback strategy can be reverting to a commit or, you know, patching a new commit on top of the current branch, you know, like it becomes like very easy to move your infrastructure to certain points in time if needed or roll forward. Thirdly, approved changes can be applied automatically to the system. So what I mean by this is that proposed changes to the system all go through your standard version control flow, whether that's PR or peer review, or just like pushing commits directly. And once those commits have been pushed to your Git repository, they should be able to be applied automatically to our infrastructure. And then the vehicle by which this is done, it leads into the fourth point, which is that there exist software agents to ensure the correctness and also alert on divergence. So we talked a bit about like infrastructure drift between expected state and actual state. GitOps introduced software capabilities to ensure that your expected state is always being converged on the actual state. So I hope that makes sense. Also, I'll take a pause here and mention that GitOps it's a principle. It is not associated with any one platform or tool. So in this presentation, we're going to talk a bit about Kubernetes and Argo CD, but these things can be applied just as a more like broad sense. It doesn't need to be Kubernetes specific. One of the reasons why GitOps has really developed more recently around the Kubernetes ecosystem is because Kubernetes as a platform has a lot of controls built into it in terms of like state reconciliation. Everything is controller driven within a Kubernetes ecosystem. So it's like constantly reconciling state, which just works really well with GitOps and these principles of, state conversions. So let's talk a bit about the GitOps operator. So this is kind of like the blueprint for implementing GitOps, irrelevant of the actual tool that you use. So the first part is that you need to have some mechanism by which to retrieve manifests. So these can be manifests in a Git repository. These can be manifests in a Helm repository. It just needs to be stored somewhere that's versioned. So yeah, being able to clone a repository and then run configuration management tools such as Helm or Customize. Secondly, a GitOps operator needs to be able to visualize deviations. And I would actually push back on this a little bit and say that it doesn't need to be visual, but it does need to be able to compute a delta between the actual state and the expected state. So that way it can, which leads into the third point, apply changes and push an updated manifest to a Kubernetes cluster in our use case, because we're going to be talking about Kubernetes a lot. So it needs to be able to clone repositories. It needs to be able to visualize or compute diffs, and it needs to be able to apply those changes. So that's kind of what the life cycle of the operator is. Next up, this is actually the Argo CD implementation of that design pattern. So the component that retrieves the manifest is called the Argo CD repo server, and that's what you're seeing here on the right. And so all that that's responsible for is pulling Git repositories and cloning them. So it contains just, stacks of directories that have all these Git repositories or Helm repositories, and it can be at like any version, any commit in time. It also contains all of your tools that are needed to render the templates, the manifests for your Kubernetes cluster. So it contains tools like Helm and Customize. You can also sideload any binary that you want into the Argo CD repo server that will render a valid Kubernetes YAML. So what I mean by that is if you're doing something really custom and say like you're already familiar or your company has adopted a specific templating engine, you're not constrained to use the tools that are supported out of the box with the repo server. So say you're using Jinja, you like it as a templating language, or maybe there's a higher level abstraction. Maybe you're using like an actual programming language to generate Kubernetes manifests. As long as the binary exists on the repo server to generate a well-formed YAML output, you can use it in this ecosystem. So that's what the repo server is for. Next, there's a UI component to Argo CD. And I'll show you what that looks like in just a sec. That's called the Argo CD server. So this serves as both an API server and it also visualizes those changes. So we talked about the second bullet point and the operator pattern for GitOps is that it needs to be able to compute deltas. So that's what the Argo CD server does. It's an API server and it also is a UI and it will show you what the differences are between your states. Okay, cool. I thought I was going to hear a question. Lastly, the apply changes on push component is controlled by the Argo CD application controller. So this is like your standard Kubernetes controller made with KubeBuilder. It's like a Kubernetes controller and it manages custom resources, which I'll talk about in the next slide. But this is the thing that is like the meat and potatoes of the system. It's like constantly receiving a stream of events to like unmarshal and marshal manifests and then apply them to your live clusters. So Argo CD is a Kubernetes native construct. It runs in a Kubernetes cluster and it also manages other Kubernetes clusters. So you can use it as like a hub and spoke model where you have like a central Argo CD installation that's managing the cluster that it runs in, as well as any clusters that it's connected to. And then, of course, there's caching in between each of these layers. So as you're moving into GitOps, it can become quite taxing on your systems because you're going to be pulling and cloning repositories probably much more frequently, and you're probably going to be hitting your API servers much more frequently. So just keep that in mind. So these are the two custom resources that Argo CD introduces. It introduces a resource called an application and an app project. And I'll start by describing what the application is. So the application is just there's a motorcycle going by. You might hear some background noise. The application is a definition of the target Kubernetes cluster to deploy to, the target namespace to deploy to in the Kubernetes cluster, and then it also defines the source repository, so where it should be pulling the manifest from, along with like information like the directory in that repository or even the branch to use in that repository. So that kind of like allows Argo CD to know like where it should put the things that you're asking it to manage. That's one way to think about it. Next, the app project is actually just a construct to introduce role-based access control into the Argo CD ecosystem. So it defines a list of Kubernetes clusters and namespaces that can be accessed within a given project. Oh, I misspelled defines. That's okay. It also defines a list of Git repositories that can be accessed in that project. And lastly, it has like OICD group bindings, OpenID Connect group bindings. So this means that you can use SSO with Argo CD. And actually that is like the way to log into the UI to authenticate to Argo CD is via SSO. There's like one admin account, which is local, and you can add other local accounts, but it's recommended that you use, your standard SSO provider, whether that's, Keycloak, Dex, GitHub, whatever SSO provider you use, you can integrate that with Argo CD, and you can just start onboarding teams that way.
Isaac, I have a question.
Mhm.
Now that I see the architecture, and I don't really know AWS that well, but can this work in an AWS environment, or is it really more native to like more of a pure Kubernetes environment?
It is a Kubernetes environment tool. So you can use it in AWS if you're running your Kubernetes clusters in AWS. You can also run it on-prem or in a hybrid environment. Argo CD is like very agnostic in terms of the actual cloud provider that you're using or not using. All it cares about is managing state within Kubernetes clusters.
And who have you seen to be the sort of the community that has really embraced it? Is it more of a Google? Do you see more Google GKE users than AWS?
That's a good question. I think in general, AWS has the lion's share of the cloud market in terms of running Kubernetes clusters. I think GKE and Google obviously know how to run Kubernetes really well since they created the project. But I would say by and far, probably AWS-based deployments. Yeah.
Interesting, because AWS has so many tools, that,
Mm-hmm.
like everybody's uses right away cloud formation. So it's interesting
Mm-hmm.
that Argo has been able to kind of push their way into that space.
Yeah, yeah. So Argo, it is a deployment tool, so it works like nicely with like other like tool chains in that sense. And actually, the company that is the maintainer, the core maintainer of the Argo project is Intuit. So, they're like a large financial institution. And
Yep.
so they work really closely with companies like AWS and Red Hat. So Red Hat just joined the Argo project as a core contributor. And I know that Intuit works really closely with AWS because Intuit is very much a AWS shop. They use EKS. They're all cloud, like a cloud native company. So I wouldn't be surprised if in like the coming months or quarters, you see this type of offering made as like a managed service within AWS. That's just
Right.
speculation on my part, but
It would make
that's kind of,
sense. It would make
yeah,
sense. Yeah.
yeah, that's kind of the trend of AWS services is like you see something in open source and they try to roll it into a managed service.
Right. Thank you.
Yeah, good question. So now we're just going to just click around in the UI. I'm going to put this link in chat. I'm going to try to put this link in chat, which is a public Argo CD installation. Oof. I need to relocate my chat. Chat. Q&A. Oh, Q&A.
You should be able to just float down and that your menu bar at the bottom should pop back up and you should have a chat window.
Oh, okay. I see it. Thank you. Cool. So that is the link. Did it not? Am I on the internet? What is happening? Interesting. Well, I hope I don't need to do this all. I can do it all local. And in fact, I am planning on showing some local thing. But I wanted to share this because this is like an Argo CD installation that's publicly available. It's managed by Intuit. And that way folks can actually click around instead of just watching me click around. But it looks like it's not available. But it was
Yeah,
like 5
I'm
minutes
getting
ago.
the same thing as you are. I just clicked on the link and I'm getting, it looks like it says waiting for cache, so.
Oh, so sad.
Well,
Oh,
maybe it'll
okay.
come up.
Wait, it just came back. Oh,
Great.
you know what happened? This is really funny timing. And actually, I wanted to talk about this because Argo CD is all it does is it like runs kubectl apply at the end of the day, right? It just creates things in Kubernetes. And because Argo CD is a Kubernetes native construct, it runs in Kubernetes, it can manage itself, which is like kind of meta. And so what we just witnessed there was Kubernetes upgrading itself. So you can see this is the Argo CD UI. Every one of these boxes is an application. And remember, we talked about applications. They are an association of a Kubernetes cluster, a namespace, and then a Git repository. So you just saw this box for Argo CD go from blue to green, which meant that it was going from a progressing state. So there was a change that was being applied to a healthy state, which meant that the change was successfully applied. So let's consider ourselves fortunate that we got to witness that. That was kind of cool. So you can see that if we click into the application view, we kind of get this detailed summary. And every one of these boxes is a resource in Kubernetes. So I'm going to be using a lot of like Kubernetes specific terms. So if you need me to clarify any of those things, let me know. So you have things like service accounts, custom resources. Here are the replica sets. There are pods. If this is looking too busy, you can also come up here in the top right and click filter. And then you can just start filtering out stuff. So maybe I just want to look at the pods. And in this case, these are all the pods that are running for this Argo CD installation that we're looking at. It is self-managing itself. So what that means is that if I ever want to upgrade Argo CD, all that I need to do is make a commit to a repository, and then it'll go ahead and see that there's a change, and it'll reconcile the expected state, which is in Git, with the actual state, which is running in your Kubernetes cluster. So that's kind of cool. You can like click into these as well to see even more details. So it'll tell you like what image is running. It will give you an output of what the live manifest is. And you can even see things like Kubernetes events. These are just native Kubernetes events, as well as logs. So you can see the repo servers like pulling things. We talked about the responsibility of that, just to clone repositories. Yeah. So you can feel free to click around here. It's read-only access, so don't be afraid about deleting anything. You can do no harm. Additionally, there's a settings tab, so you can see like all the repositories that are connected. Apparently this one doesn't have any set up. You can also see the projects. So we talked about projects being like the RBAC of the system. So one thing to be cognizant of when you're starting your GitOps journey is that by introducing GitOps into your system, you're kind of implicitly breaking down the barriers of RBAC that exists within Kubernetes. So because people can apply changes to your system just by a commit, you just want to be aware that whoever can access your Git repository can probably change your infrastructure. So just be aware of that.
Okay,
So,
I have another question.
mm-hmm.
Can you tell me what an application is again?
Yes, yeah.
My head keeps wanting to tell me it's something else, but I don't think it is.
Yeah. I'll show you the actual like spec of it. So the actual manifest looks like this. So this is what we're looking at is a custom resource. And the custom resource of an application defines the Git repository to pull from. It defines a path in the Git repository. It defines a branch or a target revision. So this could be, main or master. It could be like a feature branch, or it could be a commit. And then it defines a destination server. So in this case, it's using the default Kubernetes server, which is the in-cluster server that Argo CD is currently running in. And then it defines a target namespace. So you can think about this as at a high level as like, this is my expected state, and this is where I want to apply it, and this is where I'm going to check for the actual state. And to kind of make this more concrete, if I open the repo URL, you'll see it takes me to a Git repository as we would expect. And inside of that, there's a subpath, so path, Argo CD. We're going to click into Argo CD. And in here, there's the customization for everything. And you can see that someone actually just committed an hour ago to upgrade it, which is what we just saw there happening. We saw Argo CD upgrading itself. And so all of these are manifests. They are YAML files that can be applied to a Kubernetes cluster. So Argo CD is just taking the manifest it finds here and applying them there.
And is an application, is it associated to a pod then?
An application can create pods, but it doesn't need to. It's not tied to a pod. It's just like it is a custom resource in Kubernetes. Yeah.
Okay.
I'm kind of curious what the commit looks like. Okay, so here's like an example of what a commit looks like to upgrade an application or to change an application. And we're actually going to go through this process here in just a second, so it'll be a little more concrete. So I'm actually going to switch gears here a little bit. Feel free to continue poking around in this if you want to kind of familiarize yourself with the UI. But we're actually going to pivot into actually creating an application from scratch. So here I have Argo CD running locally. You can see my applications that I've already set up. So how we create a new app. First, you can do it a couple different ways. You can create it via the UI, which I'm going to show you here. But in practice, everything should be created declaratively, meaning that your custom resource definitions will be checked in to version control. Nayland asks, have you used Argo CD in a production environment? If so, how's your experience been? And how have you handled application configuration and DB migrations associated with code being updated via Argo CD? That's a good question. I can't really comment on my use of Argo CD, but from the chat or the Slack channel that there's like an Argo CD Slack channel, which I'll share at the end. A lot of folks are adopting this in production, and their experience has been like very positive. Like it helps reduce the cognitive load of doing upgrades and rollbacks a lot. Also, it's very scalable and stable. I would say the largest user of Argo CD in production is Intuit themselves, who run at like a humongous scale. Like I would recommend like following them if you are interested in learning about how to run Kubernetes at scale. And specifically the question of handling application configuration and DB migration. I would say for the first part, application configuration is very simple. Like all that is required is like committing a change to your source repository. So say if you want to change the image tag, that would just be a simple edit of either the actual YAML file or a templated version of the YAML file. And then you push that. And once it's pushed, that's where GitOps takes over. Now for DB migrations, it's a little different because those are like one-off tasks. There are things that you can do in Argo CD that perform one-off tasks, but it's much more proficient at doing like an entire state reconciliation rather than just doing like one-off tasks. There are things that are called like pre-sync hooks or sync hooks that allow you to execute arbitrary jobs before, during, and after your deployment. And I have heard of people using those to do like DB migrations. So I hope that answers your question. Okay, so we were talking about creating an app. So you can create an app in the UI just by clicking New App. We're going to give it a name, calling it Demo. The project, I'm just going to give it the default project, which has access to everything. Sync policy, you get two options here, manual or automatic. Manual means that you need to sync the changes yourself with a command or a button click. And automatic means that once the code is committed, Argo CD will automatically apply the change. So I'm going to click manual. I'm going to click auto create namespace because I'm going to create a new one. And here's the list of repositories that I have added locally. I'm actually going to use the upstream Helm chart repository. And so you can see that it knows that it's a Helm repository. Also, you can tell that the repo server is doing its work because the moment I put in this repository URL, it went ahead and cloned it. It's doing a shallow clone, and then it's listing all the directories in there that look like Helm charts. So this is kind of like a quality of life thing. So Argo CD will look for Helm charts or customized manifests that exist within a repository, and it'll just list out the applications. It'll list out the things that you can install based on what it finds. So in the case of Helm, it's looking for the chart.yaml. And in the case of customize, it's looking for the customization.yaml file. So that's how it's pre-populating this dropdown here. And I'm just going to install everyone's favorite WordPress. 90% of the internet runs on WordPress. Don't quote me on that. And then here I'm picking a version for this chart. So charts are all versions, so I'm picking the latest. And so for cluster, I only have one added. I'm just going to click the default one. And the namespace, I'm going to call demo. And finally, you can see here that it's giving us the option to configure some things that are not checked into version control, or they're just like not defaults. So here's the full values.yaml file associated with the WordPress chart. And here it's just giving us some options to change the parameters. So I think all of these look good. The only thing that I'm going to change is the service type from load balancer to cluster IP. And now before we apply this, I just want to show you what it looks like as YAML. Because like I said, the UI is just like a convenience thing. It's not really needed to run Argo CD, but it definitely is useful to have. You never want to create applications with the UI because it breaks the declarative model of GitOps, because no longer is the source code for the application manifest in your Git repository. It's just like being created in, at CD. It's like a custom resource, so it'll exist in your Kubernetes cluster. So you always want to make sure that everything you're doing is reflected back in source control. So here is the application, the full application spec. This is the custom resource of the application we were talking about, which is the YAML version of what we just created via the UI. So you can see that I gave it the name. You can see the destination. So that's the Kubernetes cluster it's running in. And then remember, we have a source. So in this case, I gave it the repo of this Helm chart repository. And then you can see that I'm installing the WordPress chart at this version. And then here you can see like the custom overrides that I added. So I'm going to say this looks good. I'm going to hit save. I'm going to hit create. And you can see it just popped in here as a new application called demo. And if we click in here, you can see all of the resources that can be created as part of this Helm chart. And so at this point, you can put yourself in the mindset of like, I'm an operator doing a deployment. And so what we're going to do before we apply is we're going to check that everything looks like we expect. So how we're going to check this, remember bullet point 2 of the GitOps operator model is that we need to be able to compute deltas. We need to compute changes and visualize them. So the way that Argo CD does that is with this app diff function. So I just clicked app diff and it brings up this nice little view. Anything in green is an addition. Anything in red is a deletion. And as you can see here, we only have additions, which is what we expect. This is the first time that we're deploying this application. So we have things like the config map. We have some persistent volume claims, some secrets, some services, and then the actual deployment. So as an operator, I'm like reviewing this all and making sure that the changes that are being entered into the system look good. And once I say like thumbs up, look good, we can click the sync button. Now what the sync button does is it's going to actually go ahead and apply these changes. It's going to do the deployment for us. And after clicking sync, it's going to show you some options that you can tune. So you can also like delete things that are no longer needed with the prune. You can also selectively just apply specific things. In this case, I'm just going to leave all the defaults as is. Before I do that, I'm going to show you that there is no funny business happening here. Oh, cancel. So specifically, we're deploying this to a namespace called demo. So I'm just going to do kubectl get namespaces. Let me make this a lot bigger. And you can see that there's no demo namespace. There's gdemo, but there's not demo. I made that just a couple minutes ago. So I'm going to go ahead and sync. So you can see things are starting to get created. Already a lot of stuff is in a healthy state, meaning that it's created and in the correct state. You can see that our WordPress pod is coming up. And we can click into it to see some more details. So we can see events of, okay, it was assigned to a node. The container was already present, so I didn't need to pull it. It was cached. And it's gone ahead and created the actual container and started it. And if we look at the logs, you can see that WordPress is actually starting. And let's go ahead and do our grep again for the namespace. And you can see that demo namespace now exists. Like we literally just made that. So I'm going to switch over to demo, and I'm going to run watch kubectl get all. So these are all the resources that were just newly created. You can see by the age that they didn't exist just a minute ago, and now they're coming into existence. And it looks like everything is synced and successful. So I'm actually going to go ahead and check that WordPress is up and running. Pretend this is your enterprise website. So I'm going to do kubectl get service. I see WordPress. So I'm going to grab that and I'm going to port forward to it just so I can see it. So I'm going to run kubectl port forward svc for service, paste my service name, give it a random host port, and then give it the port that is bound to in the container. Oops, did I mean port forward? I sure did. Cool. So now if I come over here to localhost 9998, oops, 8, bada bing, WordPress is running. Feel free to applaud.
Very nice.
Creating an application is one thing, but updating it is another thing. So this is where we're kind of moving from like day one operation problems to day two operation problems. Like, how do I make this an ongoing thing? How do I introduce changes into my system? So I'm actually going to use just a sample Git repository here. There's really nothing to it. I'll put it in chat, but it's just a default Helm chart. And I'm going to create a new application using it. You think there's a question coming in? Is there a question coming in? Oh, question from Vlad. Does Argo CD support event-based architecture? For example, is it possible to deploy manifests after successful completion of pull requests in GitHub repo? And how easy is it to do? Yes, it does. So Argo CD by default will pull your Git repository every 3 minutes. But you can also add a webhook to do like an event-driven approach. So here in the docs, there's an example of how to do that. There's an endpoint called /API/webhook, and that will be used to trigger an event in Argo based on the events that you've configured here. So in this example, you're saying for this repository, on every push event, call this payload. And so Argo CD will see that event get triggered. It'll, clone the repository. It'll check for changes and it'll apply changes. And so in that case, yes, it is possible to deploy a manifest after successful completion of a pull request. And that's like exactly how the system works natively. So when you have a pull request get merged, you can also set that up as an event to trigger this webhook. And so the moment it gets merged, it'll go ahead and do the whole state reconciliation we've been talking about. So very easy to do. Good question. This will also help relieve some load from your version control servers because it doesn't need to pull it every 3 minutes. It's just getting events as they're coming in. So yeah, good question. And I'll show you here how you can do that. So I'm going to really quick fly through making and updating an application. So I'm going to go through the same process for the repository URL, sync policy, repository URL. This should be auto-completing. Let me try refreshing the page. Oh, I was using the public one. Okay. So I'm going to call this Isaac demo using the default project, auto-create my namespace. I'm going to choose my personal GitHub, so GitOps demo, which is the link I shared in chat. And then the path is just current directory. Put it in my current cluster, put it in a namespace, name it after myself, and I'm going to say create. And so now you can see the same type of view that we saw before, just a bunch of different creations. This one's really simple. It's just setting up Nginx. So I'm going to go ahead and sync that. I'm also going to come over here and switch to the newly created namespace. And you can see it's starting to spin up my pods and my service and my deployment. And so now Nginx is up and running. And I can show you that it's running just by port forwarding to it. So I'm going to do that same process of port forwarding, port forward, SVC, blah. I'm going to use 9998 again and port 80 because Nginx runs on port 80. Okay, so let me back up a couple steps. What we did so far is we set up a new application. and we're pulling from this repository. I put the link in chat if you want to look at the contents of it. And the changes that we're proposing are these ones. So we're changing an image tag, and then we're just changing some resource limits to the pod. So like very trivial changes. This could be any type of change. It could have been, upgrading the version of our application to, the next blessed version, or it could have been like updating an ingress or host name. It could have been really anything. So I have that commit right here. You can see I just added changes to Nginx. And so now I'm going to go ahead and push it. And so if I come over here, you can see that I just committed this change, adding changes to Nginx. And now if I come over here, give it a quick refresh. No, hello. Did it already apply it? No, it didn't. Oh, let's hit this refresh button. Okay, so that was one of the things that we were talking about in chat is the pull-based model versus the push-based model. So I just asked it to refresh it, which is just a way of saying, go ahead and clone the Git repository again and tell me if there's any difference in state. So now if I check the diff, you can see that there are changes. I'm changing the image tag, and then I'm adding these resource limits, which is exactly what I wanted, because remember, Git is your source of truth. And because I push those changes to Git, Argo CD is trying to reconcile the state of the actual world with what's in Git. So you can pretend we're doing a deployment right now. We're reviewing our changes. We're approving them. We've gone through the PR process, so our change has been reviewed by our peers, approved and merged. And so now the only thing that's left to do is hit sync. And that's it. It's that easy. So at this point, like Kubernetes is just going to do its thing. It's going to spin up a new pod. It's going to delete the old pod. And the new pod will have the new configuration that we specified. Cool. That's it. Nice job. Thank you. So that's the end of the demo portion. All that's left is to just kind of share with you how you can get started. So there's the GitHub to the Argo project, which I'll drop in chat. Thank you for the great work. You can also engage with the community. The Argo project is very active. There's an Argo project Slack. There's also a channel in Kubernetes called #GitOps that you can join. And people will just chat more generally about the GitOps tools that are available. And then there's also monthly meetings for Argo CD. So there's a meeting on the first Wednesday of every month at 10 a.m. PST to talk about Argo CD and also Argo rollouts, which is another part of the Argo project, which is more focused towards progressive delivery, which is basically continuous delivery with more knobs to turn. And then there's also an Argo CD contributor meeting every Thursday at 10 a.m. So that was actually today at 10 a.m. So if you're interested in contributing back to the code base, you can join that and they'll help you get ramped up. Everyone's pretty nice about helping people get started with Argo CD. And then here are just some references at the end for GitOps and continuous deployment with Argo CD. Cool. That's all I have. And if there's any questions, I can answer them. Is Argo more like Rancher or Spinnaker? So I'm not too familiar with Rancher. I think it's like a platform that runs on top of Kubernetes, right? And then Spinnaker is actually, in addition to being a deploy tool, it's also a build tool. Spinnaker Kubernetes. Oh, there it is, spinnaker.io. So the cool thing about Argo CD is that it's not a pipeline tool. So it's not a replacement for your Jenkins or your Spinnaker or your drone or your Circle CI. Argo CD is only interested in doing the deployment piece in the CI pipeline. So you can still use Spinnaker or Jenkins or Rancher. I don't know if Rancher does builds, but you can use those tools to actually build your container images. And then the last step can be Argo CD, just handing it off to Argo CD. And that can be done via a commit at the end of your build pipeline. Or there's ways to trigger a change that don't involve a commit, which we took a look at a little bit with the parameter overrides. Okay, the next question is, are there APIs or CLI to call Argo CD? Yes. And I can actually share that a little bit. So there is an API that you can develop against. Built in, there's like a Swagger documentation, so you can see like all the things that you can interact with Argo. It also has native Go libraries, which I would recommend using because like this documentation is not always the most up to date. There's also a CLI. Excuse me one second while I open the chat here. So there's also a CLI, so you can do Argo CD version or whatever. And so it gives you the server version and the client version. You can also interact directly with your applications. So I can do a fun thing here, like my demo app, say like I'm done with it. So I can do Argo CD. I think it's app list. And it will list out all my applications that I have running. And you can see one of them is demo. So I'm going to do Argo CD app delete demo. And you can see it's already going ahead and deleting it. So yes, it does have an API and a CLI. The CLI and API are both very robust. So you can like kind of plug and play with it in the event where like Argo CD is not meeting your use case specifically. You can extend it using the API and the CLI. Yeah, good question.
So anyways, thank you, Isaac. It was fabulous. That was a really great presentation, more than I was expecting. And I'm very excited about Argo CD now. So you did your job.
Awesome.
And everybody, we will see you on the next one, which is November 10th. And I will be I'm going to download this from the Zoom webinar, and I'll get it uploaded to the YouTube channel. We don't have I need to load it to the Deploy Hub YouTube channel for now, but I'm going to hope that I can get the CD Foundation to upload it to their channel so it'll be easier to find. So thank you again, Isaac, and everybody stay safe in the world of COVID.
Thanks for having me.
Absolutely. Thanks. Bye-bye.
Bye.